Alright, ready for question 2? We want to sketch g of x. We have a third order polynomial, but how is this one different from the previous one, Richmond?
It's not factorized.
It's not factorized, and because it's not factorized, it can limit some of our options to be able to graph this. In some instances, if I saw this on an external and I had a calculator handy, you'd reach for your calculator.
Yeah.
But we're not going to do it with a calculator for this one. And the reason for that is we are going to expand our knowledge and our toolkit on what we can do when we don't have technology available, which will be the case for your SAT. Let's have a think. If I said g of 0, what would the y-intercept be?
12.
It would be 12. Now, if we think back to the previous example of how did we determine the y-intercept, what did we do? We got all of the roots, so x plus 3, x take 3, x, was it plus 2? I can't remember. And it was like, so like that. We got all of these and we just did that, which gave us 6. And the point I'm trying to make here is we could predict the y-intercept, or we could predict what would be the constant term by multiplying all of the roots together. And because of this, we have a lead on how we might determine what the factors might be, and if we know what the factors are, then we can graph this. Now, because this is third order, if we can get one factor, it means we can reduce it to a quadratic, and if it's in a quadratic, we can easily factorize these. So the first point I'd think about when I'm trying to graph this with our technology are, what are the factors of 12? So factors of 12, what are they? 1,
2, 3, 4, 6
times 2 times, well, let's just say 1 times 2 times 6, what else? 1 times 3 times 4. Now this is a third order, so how many factors are we looking for here? 3. Looking at this, I could break the 4 into 2 times 2, but that'll give us 4 factors, so let's not do that. Let's just keep it like this. So, based on this, what's most likely going to be one of our factors here? What appears the most?
X plus 1.
2 appears once, 6 appears once, 3 appears once, 4 appears once, 1 appears twice. It appears across both of our lists of factors, so what's most likely going to be a factor here? 1. Alright, let's go back 2 lessons and think. Factor theorem. If I substitute in f of 1, if 1 is going to be a factor, or let's say, no, let's go, if 1 is going to be a root, what do we expect to get out of here?
12.
If 1 is a root, then f of 1 is going to give us what? If 1 is a root, where do the roots occur?
Negative.
Where do the roots occur? F of x equals 0.
0.
So if 1 is a root, then this is going to be the case here.
Yeah.
Now, if 1 is a root, hence x take 1 must be a factor. Does that make sense?
Yep.
So this is the factor theorem. If 1 happens to be a root, then f of 1 would be 0, and if that's the case, then hence x take 1 must be a factor. Now, how would we see if that's actually the case? What tools do we have? Math. We can sub it in and just check that it actually works, or what else could we do just as easily? Could we divide?
Yeah.
Linear factor, what's the most capable or the fastest way to do the division here? Synthetic. So let's go, if this is the case, so if we've got our x take 1, then our k is going to be -1. So setting up for synthetic, we've got -1, 1, -2, -11, 12. Okay, working our way down, that's always 0. Accumulate times. That's going to be accumulate, so that will be 8 times accumulate.
Would k be just 1, not -1?
Because we're assuming that this is going to be a factor. And if that's going to, oh yeah, sorry. My bad. So that should be a +1.
Yeah.
Good thing you're listening. This will make everything better. Let's start again. That will be 1. This will be 1. This will be -1. This is going to be -1, this will be -12, this will be -12, and this will be 0. Therefore, x take 1 is a factor. Making sense so far? Suppose we took a gamble and we said that you can see there's negatives in here, don't you? Which means some of these factors are going to be negative. Suppose we took a gamble and we didn't say 1, we said -1, and we went down this original path which I started going down, not because I thought it was that way, but because I made a mistake. What would it tell us if we got a non-zero value here?
It must be the other side.
It's actually not a factor.
Yeah.
So what I'd do is I'd reverse the 1 from that step, and I'd try again.
It would be, it'd be not safe, but if you make it -1, you can always just change it sign to a plus afterwards.
Yeah, you can. But
It doesn't pay up, then you don't have to like rewrite.
yeah, you can. But yeah, the point being made here is you're going to try this and you won't always get it the first time around. It's just the reality of things. So a mistake is kind of a good thing. But needless to say, we got there in the end. So now we know x take 1 is a factor. What should we do next? You could, but what will that tell us? Nothing we don't already know.
Yeah.
Rather, what we can do is we can write g of x in a partially factorized form. We know that x take 1 is a factor. Since we know x take 1 is a factor, we know that when we take this factor out, we get a quotient of x squared, take x, take 12.
And we do love a good quadratic.
We do love a good quadratic. What am I missing here though? No, we're not actually missing out. We don't need it because
there's no a because of
we didn't
x cubed is
we didn't manufacture the equation up here. We've got it through factorization, but I did think about that as well. So good thinking. I'd rather you put it there and then discover that you didn't need it rather than forgetting it and then discover that you did need it. Okay, from here, can we factorize quadratics?
We sure can.
Okay, what would the factors be here? Knowing that, we thought about these.
-4 and 3.
Happy as Larry?
Larry is very happy.
Hence, the roots at x equals -1, x equals -4, and x equals, x equals 1, x equals +4. Wow, I'm off my game today. And x equals -3. Now looking at this, where's our y-intercept going to be at?
-12. Or no, 12 actually.
Y equals 12. I am off my game. So if we graph this, we need to fit 1, 4, -3, so I get 4 up here, -3 down here. I'll just slightly asymmetric. We've got 4 up here. We've got 1 over here. And we've got -3 over here. I know I'm going to go through y equals 12. So that's going to be 0, 12. And because this is here, I know it's going to go whooshka. It's probably, so local maximas there, local minimas there. Arrows, arrows, y equals g of x. Reasonable?
Yep.
So the takeaway from this one is, it's unlikely you'd get something like this, but we need to prepare, and it does give us a good understanding of how these things work. We can graph these without a calculator. However, we have to go through a trial and error step where we have to guess what the factors might be given the constant. And from there, you just pick the most likely and you work your way down.
We can just keep in mind that, yeah, since the y-intercept since it's positive, 2 could be negative.
Yeah, it could be.
If it's positive, then they're all positive, or 2 are negative.
Yeah, exactly right.
And then,
You've also got that as a clue as well, because there's negatives there. You know it's going to be trouble.
if it's negative, 1 is negative, or 3 is negative.
Yeah. If you saw this on an external, you'd go straight for the calculator. If you see this in an SAT, because part of the next SAT is going to be without calculators, this would be fair game, and what we would be assessing is, do you understand where the y-intercept has come from, and could you work backwards from it? So it's necessary for now, but once we get past this topic, it's no longer necessary to know this, but it does help to know it. Cool?
Yeah.